So the purpose of this is to remind ourselves where this working group on materials resource registries has been, what it's done, and most importantly, what's happened since we formally finished as a working group. The work is ongoing and hopefully has good connections to the new work that's happening within the interest group. And so this talk is to try to make those connections. And so just to remind ourselves what the goals and accomplishments of this working group is, we set out to create a working demonstration of a federated registry system that was specifically meant for discovering data resources that's useful for material science and engineering research. And so we put together a two-node federation. Excuse me. And those registries are powered by a common XML-based metadata schema that has both a discipline's generic component and a material-specific component. In particular, that material-specific is dominated by what we call the material science vocabulary, and that's one of the kind of the outputs of this work. And then we have an architecture for these federated registries in which all the records are exchanged between the nodes using OAI PMH. So if you can visit either of those two registries, you'll see the same records thanks to this interchange. And this registry content is restricted to pretty high-level resources. We're talking about repositories, databases, websites, not individual data sets. The idea is to allow people to find out where these repositories are and then drive the users to those sites. And it's also part of an architecture in which there could be more machine-driven discovery, in which the registry is the first layer in that discovery process. So we created a final report. It admittedly took longer than it probably should have, but last year at Helsinki, we rounded up the final review of that report, and that report is now available on the working group website at that URL there, but I'm also going to paste that to the chat as well, so you can see that. This report is more than just a report of what we did and how it all works, but really was meant to lay out what the architecture is and the requirements for a federated registry system, so it could serve as a roadmap for any other community that wanted to come along and implement a registry for their community. What were the parts? What are the things that they would have to plug into that? And that architecture is implementation, indifferent, if you will. So I'll also mention that this report actually is been submitted as 2 papers to the CODATA Data Journal, one on the registry architecture and system, and the other on the metadata schema and the vocabulary. And that, that should be coming out in the next year. So as I mentioned, the work is ongoing. So I wanted to say a little bit about what's been happening since we formally finished our work. In particular, the software that was developed to support this this pilot is still being developed and extended, and new features added to it. The registry software was developed by a group at NIST in the Software and Systems Division in the Information Technology Lab in a collaboration with MML and this working group. And the registry software itself is a specialization of a more general purpose software system called the Configurable Data Curation System. And it's a product for allowing you to create metadata records about things using a customized XML schema, okay? And since we've been using the software as a registry, again, more features have been added, and I want to highlight a few things that I think are important for registries. One is that there's a strengthened support for just PIDs and record linking. That is, support for PIDs is built around a very general PID model. It has built-in support for handles, but really you can plug in any kind of PID system that you would like. And the whole idea for this very general model is to support generally and flexibly the ability to link records together, not only records within the registry, but records in the registry to things outside the registry, and things outside the registry can point to records dependably in the registry, thanks to a strong support for PIDs. And there are some other features that are coming out that we're working on. Very soon there'll be this feature for customizing how users can register for an account on the registry so that they can create records. And we're looking at improved sort of group-based workflows where you might have several people working on creating records that go into the system, that they would collaborate together on that. And a bit more about how we operate these registries. As I mentioned, we have 2 nodes working in the US, and there's a third that may be coming from the UK, and I'll say a little bit more about that in a minute. We've also added support for 2 new resource types, and to explain what I mean by that, we can actually visit the registry here. So can you guys see
yes.
The registry? Yes, let me just try to blow it up a little bit here. Okay, so if you visit the registry, you'll notice that there are these different types of things that you can find in it. There are organizations, there are databases, data collections, services, informational sites, and so forth. So different types. And the idea is that these different types can have slightly different kinds of metadata associated with them. And 2 types that we've added in recent times are support for materials-related software, and most recently for semantic assets. And you're going to be hearing more about what we mean by semantic assets in the next presentation. But basically, we're talking about we can register things like vocabularies, schemas, registries, ontologies, anything that is about sort of capturing the semantics around our research that might be useful for building out systems. And so, so I'll just give you a little view of what that is. Okay. And I also wanted to give you some highlights of the kinds of things that are in there that you might expect to find if you do a search. So for instance, if you entered a search of interatomic potentials, you can see there'll be a number of things that come up. Resources that are related to that area of research. It's not the potentials themselves, it points you to the repositories where you can find these things, like the interatomic potentials at repository at NIST or Open KIM that actually house the actual calculations. But there are also resources there that actually use these potentials for other applications, such as the Jarvis FF. So so you can find a variety of kinds of resources for a given topic, and you can dive deeper into some of the metadata. But most importantly, you can click on the link to the repository itself to get at the actual data and data-specific tools. If you were to look for atomistic resources, you would find things that cover a variety of scales, from the atomic scale, electronic scale. You can find databases and other things. So one of our collaborators in this is Chandler Becker. She does a lot of curation of the records in this area, and she has focused on certain areas to really try to build out the coverage for resources that we know about and those of our colleagues. And so she reaches out to people to get this information and really tries to see the collection. So we have kind of combined both a crowdsourcing approach and a curated approach to trying to fill out these records. So I want to tell you a little bit about a prototype that's being developed in the UK at the Physical Sciences Data Science Service. This is a resource that's funded in the UK that gives access to a large variety of services in chemistry, crystallography, materials, and other related fields, and some real gold standard data and services that are available for research purposes. And they started looking at the materials registry because, well, they maintain a catalog already of kind of external data sets and tools that are related to their own data. And they were sort of acquiring records, additional records of late. And so they wondered if there was a kind of a simple, effective, but also interoperable way of providing that kind of information. And so they had a look at the materials registry to see if they could bring up an instance and load their own records into it, and then also load all the other records that are available in the Federation and make those available to to their service users. And so I'll show you that they've done that, and they've customized it for their own center with some local branding. It's actually running within a Docker container that we provided at NIST, and then they just customize it for their own use. They were very interested in having a kind of a strong visual integration with their other services, and so they're really interested in seeing how they can customize it, and in particular plug it in a more automated way to their own curation system. And so this software has REST APIs that allow you to interact with the system both and load records and search for records and so forth. So this work is just underway, and they're still working through some of the details, but they are starting to see some future things ahead. And in particular, they're wondering if they could support kind of a modified schema that is interoperable with the schema we're using right now, but can accept data from much more varied physical science domains, and again plug in with the other registries through OEI PMH. Maybe set up some interactions with fair sharing, and have some machine operable interactions with their own data portal. So this is kind of leads me to what some future activities might look like. Activities like at the PSDS and the work in semantic assets, may encourage further evolution of the registry and the schema that we use underneath. And in particular, as I should have mentioned, this is Brian Matthews and Krishnan. I'm forgetting his first name, but they're putting this together, and they're kind of interested in seeing what they can do with this, evolving the schema. And so we need to think about as a group how we might do this in the community, and what kind of platforms we should do it. Should we right now the schema is in a repo, GitHub repo, but maybe we want to kind of reorganize that a little bit to make it a little more community friendly. And so kind of we're open to kind of discussions about that, and to talk about how we do extensions. And the original schema was built with some certain extension techniques and mechanisms built in, but and so we should probably revive those and look at those. And then other kinds of things we want to be thinking about is how we connect with other systems using machine actionable methods. And that might include machine actionable records. So records that describe services that can be accessed through a programmatic interface. And then how we link things together using identifiers. So that's what future work may look like. So this is my last slide, and it answers how you can contribute to this ongoing effort. In particular, if you have resources that you would like to expose through the registry and make them discoverable, there's a couple ways you can do this, but the way we're encouraging people at the moment to do it is to use the contact link at the NIST registry, and just send us a note saying you have some resources and where you're from, and Chandler will get with you and kind of work with you hand in hand to get you set up with the best mechanism for getting the records in. And we can support a couple different models. We can just give you an account and have you create records using the system as it's set up to do, or we can have a kind of a curated assisted approach, which you might find helpful, particularly for ongoing maintenance. And so the other way is if you are somewhere in the world and you might be interested in deploying a node of this and to plug it in with your own data system, and just again make the records more available by having yet another mirror of the records, we can help you with that by providing you a configurable a Docker container, and give assistance with setting it up. So that's it, and I can take any questions you might have. I'm also going to put links to the various URLs that I mentioned into the chat. See, I'm having trouble stopping the sharing. There we go. Stop share.
So Ray, can you say something more about whatever is involved to deploy this at another site? I mean, I'm really pleased to see the UK instance of it, and is that an hour's work or a day's work or a week's work, or can you calibrate that for us?
Yeah, I think fair to say it's more than an hour's work, which is why we're really trying to offer human assistance as well as the software assistance. But if you're familiar with Docker, it's pretty straightforward. You can and most of it is the configuration and customizing it and branding it to your own site. And but once but it's not a day's worth of work or a week's worth of work.
So Ray, I had a couple questions. It's great to see it keep growing. As you know, we ran an instance of it for a while here at Hopkins, and I've been sort of moving towards catching up to the latest version. But one question I have is our data model has moved a lot. So like, what's the bar for rectifying schemas, and what to make it useful? How does one figure out if our schemas are interoperable and really functional? Is that
so? Yeah. So in the instance that you brought up, is it it was an instance of the registry using the registry schema, or was it an instance of the CDC?
Yeah, it was like 1 point something low.
Oh, okay, right.
Marcus really helped us get it up, basically.
Right. So we've had a couple releases since then, and so and we have some scripts that help migrate to the newer system. But I know that we just went through this, and you could probably use a little assistance with that, and we'd be happy to give that to you. As far as the schema goes, your records should, like when we plug in the updated schema, your old records should still be compliant.
But our new stuff that's running on a totally different data model, really, can we
the data model that you created?
Yeah.
Oh, okay.
Yeah. So it's not only ours. It's, I don't know if you've been following Citrine's new data model, GEMD or GEM.
No. Wow, that sounds interesting.
So we're looking at different kinds of assets in different ways, and the question is how much work we have to do to find a subset of what we have that's compatible, so that people in the registry could actually search and find our stuff as well as others.
Right. So not knowing any of the details about this other model, I'll say that our registry model has, again, some extension mechanisms associated with it, in which you can kind of plug in some specialized metadata for particular kinds of types of resources, or just generally. And so it may be that we can take some of that that data model and plug it into that extension spot, and make it interoperable.
Can I make a suggestion here? I mean,
sure.
Yeah, I mean, look, this sounds like something that you could answer pretty quickly as if it was hard, right? Right, if you sat down and tried to do it.
Yeah, I think it's, I'm thinking of what Bob asked. I think it's the slowest part of bringing it up for us.
Yeah, so, I mean, I think talking to Marcus or, somebody over on our side and just giving it, see what happens after 45 minutes, it should be pretty clear at that point. Oh, this is tricky or whatever. And actually that would be very valuable for us, of course, because we would learn something about, where the challenges are. We probably also could benefit from hearing about your sort of hands-on experience with Citrine's new data model. So.
And then the other question I had, Ray, was, I mean, the thing that brings the most value of the registry system is getting the most assets registered. And so conceptually, what has to be done to get to critical mass so that, it just keeps rolling? Or are you there, do you think?
No, we're not there. No, we're not, Ray.
So there are, say, we can look at, we can do a search and see how many resources there are. I mean, I would like to hear somebody's estimate as to sort of what percentage we think we currently have of the community. And I have to say, I can't assess that myself. Okay. But it may be that it's not just the number of records. It's really about how this system is connected to other systems. So for instance, if, for instance, every major materials project also had a link to the registry for finding more stuff, or otherwise ran a node of the registry, then users, that would capture a lot more usage as a result. And or if there was more tools that were, or capabilities sort of plugged in for searches, maybe that's the thing that makes for critical mass. I guess what I'm saying is it's just having 90% of the records in the registry may in itself not be enough unless there isn't this connection to other things in the network of resources. So I don't know, but I instead of me answering that question, I wouldn't mind hearing other people's thoughts about that.
I have thoughts.
Always.
I know it's hard to believe. No, I think you're exactly right, Ray. Is somebody else commenting there?
That's me. That's Bob.
Right.
Go ahead, Jim. I'll follow up.
Great. Yeah, I mean, you're certainly right that, right, you could try to list everything and then it would be wrong pretty quickly. So, I mean, the real challenge, and I guess, we'll hear about the astronomy people, of course, is whether you could go there and do something with the information, right? So the registry has to be part of a broader infrastructure. So right now we're looking at, where do we get it stood up? Do we get it to work well? How hard is it to use? Can you do the right inventory? And I think we're getting good partners. I think Hopkins is a great one. I think getting it involved with some of the MIPS and things like that Anna said, the materials innovation platforms that the National Science Foundation is funding is a great example. There could be other ones. But, in the end, it's just more work for somebody. And it's not, the question with the registry is how do we get beyond the F and fair, right? So, that's what's keeping me awake nights.
Yeah, what I would add is, we've got strong partners in Japan. It would be really great to have a Japan presence for this. And also, I think it would be fantastic if we could engage somehow the private sector and the professional societies who are providing materials, resources. Stuff can be in the registry that is, it doesn't have to be free. If it's valuable, it should be in the registry. And people that can decide if it's something they want to pay for or not. But we don't want to exclude things from the registry because they're, pay for services if they're really valuable to the materials community. So I think that's the other threshold that we would really like to surpass, is getting providers of fee-based services also registered. I mean, you guys in material science know better than I do, but commercial aspects of materials research are huge. That's different than astronomy, where I grew up, right? Where there's no commercial interest whatsoever. So I think we have to reach out to that segment as well.
I completely agree. And, I think we're almost ready in the sense that the platform is now worth their effort, right? You say, well, this is just basically a good advertising modality, right? And they could use all sorts of business models, whether it's, some of it's free, some of it's not, whatever. That's their business. For us, it just increases the wealth of resources that the materials community be interested in, and they can make their own decisions about whether they want to buy something.
If I could pause for just a moment for an administrative thing. Brittany, I'm having trouble stopping sharing. Do you have the ability to take sharing away from me by any chance?
We don't see your sharing anymore, Ray. It's
really? That's great. Oh, good.
Gone. Yeah.
You're good. Thank you.
Thank you.
I guess it's now time to move on to our second speaker, which is Zachary Trout from the National Institute of Standards and Technology. He will give an update on the informal task group on material semantic assets involving himself, Leopold Teriz from EPFL, and Vasily Bonakov from STFC.
Hello, are you hearing me and sharing my, seeing my screen?
Yes.
Okay, great. So I'm gonna give a summary of what this group has been working on. I designed this slide deck to really be published online, so I may skip through some of the slides. I assume this will be posted sort of offline after the plenary. Something's not advancing. Okay, this is a list of individuals who have participated in at least one of the online calls based on the collaborative meeting notes. So if any one individual is not listed, I apologize. I tried to extract all that information from the past meeting notes. And if you have a question at any time, feel free to stop me and ask a question. A little background. So this materials task group was launched from the Vocabulary Services Interest Group. I wasn't directly involved in the launch of this group. I joined this group after it was launched, so I wasn't on all of the first calls. And it had a number of goals associated with it that I extracted from a document that sort of established the scope of the group. One of them was centered around building an inventory of the existing semantic assets. And that's mostly what this group has been spending its time on, except less about building an inventory, but mostly thinking about evaluating and looking at a number of existing inventories that already exist. Other things that this group could work on is monitoring technology used to build and maintain vocabularies, monitor use case for actual practices for vocabularies and semantic assets, i.e. seeing them in practice, explore methodologies for publishing vocabularies and semantic assets, i.e. how do they live on the web and how do we enable people to interact with vocabularies. And finally, explore links and crosswalks between different vocabularies. We haven't mostly gotten into items B through E. We've mostly been thinking about item A in our past calls. This is just a rundown of URLs of the 7 calls that we've had. This is mainly designed as sort of an inventory such that once these slides are posted online, it's easy to access the collaborative meeting notes. One of the calls, the 5th call, was a 2-part call centered around developing a schema. Since there was just one meeting notes, I called it a single 5th call. And this is a sort of timeline of stuff that this group has been working on. So you can see that we've been going at it since early 2018. The group calls were active up until right about here in the towards the end of the first quarter of 2019. And then group calls went inactive. Despite the group calls being inactive, a number of work was going on behind the scenes. So early on, some of the work that went on is we looked at a number of different technologies and services for housing semantic assets or vocabularies or services centered around vocabularies. This group spent a lot of time leveraging the configurable data curation system platform that Ray mentioned in the last call. In our early efforts, this group used version 1.0 of the application. And then right around the time that the calls went inactive, a tremendous amount of effort went into migrating some of the stuff to 2.0. So right around June, the end of June, early July, version 2.0 of the registry at NIST went operational. So before this, it was version 1.0, and after this point, it was version 2.0. And then we immediately went into development mode of making this registry software configurable, such that you could easily plug in a new type, such as a semantic asset. So in this period of time, a lot of effort went into updating the core CDCS software to make the configurable registry possible. And then right around, I think right around the new year, just after the new year, we deployed Materials Registry 2.0 with this new semantic asset type. And I've started to migrate some of the records. And we're at a position to talk about regrouping this this group and having a follow-up call to make those calls go active. So I was just going to go through and point out a lot of the different platforms that we looked at and talked about during our calls. One of the platforms that we looked at was the EMMC Taxonda registry. And that's a registry of semantic assets. There's a handful published there. And if you look at any given one of them, there's metadata associated with that semantic asset. Another
thing that we looked at that I learned about at the plenary in Philadelphia is the metadata standards catalog up at Bath. We talked about this data platform. It has a number of different subjects that it's supporting. And if you look at the materials section, the CIF and other things are listed there. As I mentioned, this group spent a lot of time evaluating and populating an instance of the configurable data curation system. Early on, we were using one that was sort of specialized to semantic assets. At the time, it was sort of branded the schema repository and registry, and it had a number of templates for registering schemas, ontologies, and as part of this group, we sort of generalized it to semantic assets. As I mentioned, as the configurable data curation software went through its upgrade cycle, immediately after upgrading to 2.0, the application for materials resource registry was extended to add this new type of semantic asset. Is everybody still seeing my screen? I might have bumped something to make it go away.
All good.
Good.
Okay, good. This is just a view of the small extension that was added to the materials resource registry schema. So much of the schema for the materials resource registry stayed the same, and just a small section was amended. So Ray mentioned this extension mechanism, and it's a very good XML-based mechanism for adding new kinds of types, and they find their place in the schema as part of a role. So there's a number of existing roles in the current resource registry, and if you want to add a new role, it's just as simple as finding the sort of Lego block location that you can plug in a new role, and we plugged one in for semantic asset. And I just arbitrarily chose a few subtypes of semantic assets, and this list was sort of generated from some of the discussions we had in this group. Because this extension extends the existing resource registry schema, we can use the existing applicability vocabulary that the materials resource registry group spent so much time working on. So in other words, if this is a semantic asset that you're registering specifically for fatigue test data, this extension mechanism allows you to leverage the existing vocabulary in the materials resource registry. And just like Ray said, all of this is live right now on materials.registry.nist.gov. This group talked about Optimade, and they have a section on their GitHub repository for semantic assets in material science. So this is an inventory that they are maintaining. We spent some more recent time looking at fairsharing.org, which has a whole section devoted to standards, and quite a few things within the standards section of that site do focus on ontologies. So we thought it was worth looking at and evaluating if this resource could be leveraged. And myself with Leopold Tarlis and Vasily created a little section, or excuse me, a collection on fair sharing, and we intend to evaluate that and plug in some test resources before reconvening the task group. This service was also discussed during our various task calls. I just wanted to make an inventory of sort of all the things that we looked at in our calls. And and here's a search of things that might relate to materials. And here's after I clicked on a few links following through on that particular one of those particular search results. Okay. So I gave sort of a summary of a lot of the things we've done or looked at or discussed in this task group. So one of the things that we found is that there's many existing providers, approaches, and schemas for registering semantic assets. And there's some significant diversity among these approaches. And we've observed that there's many different protocols and formats for metadata and access and exchange, both among these projects and more broadly in the community. So we had a little call between myself, Vasily, and Leopold, and we talked about, well, what's the priority and what's the next steps? And these are sort of an enumeration of some of the things we talked about on the call. Do we standardize documentation, emphasize the use of persistent identifiers for these semantic assets? Encourage use of one or more of the providers that we've already looked at. Facilitate metadata exchange among these providers. In other words, there's more than one service operating a semantic asset inventory or registry or what have you. Can we get these things to talk to one another? And again, potentially revisit those broader goals that I showed, I think, on my second or third slide. I wanted to note some recent and upcoming developments. So at the end of the month, there's another conference coming up around fair convergence. And I mention this because a number of the people involved in the Semantic Assets task group, well, two of the people involved in the Semantic Assets task group attended this pre-symposium focused on materials. And what this pre-symposium workshop was focused on was this fair implementation profile and filling that out. So what is a fair implementation profile? So it's a questionnaire centered around answering questions about how you're supporting fair data principles. So this questionnaire asks a number of questions centered around findability, accessibility, interoperability, and reusability. And maybe I should go through these more slowly. So it asks you questions like, what persistent identifiers are you using for your metadata and your data? And generally, as it's asking you these questions, it asks you each question twice, once for your metadata and once for your data. And I found that very interesting and useful. And it asks questions about standardized communication protocols and authentication. In interoperability, it specifically asks which knowledge representation languages are you using. So it's an interesting thing that's going on with this fair implementation profile questionnaire. So in this pre-symposium workshop, the organizers presented this tool called the Fip Wizard, which is a website, and it allows you to answer your questions for the Fip. And I think Alicia Garmulovich is on the call, and I'm working with her to sort of fill out this Fip profile to simultaneously get a feel for what the tool is doing and answering the questions for Alicia's project. Interestingly, every answer to the question on the Fip is a pointer to a persistent identifier to something that either exists in Wikidata or as a nano publication. So here's a pointer to under findability. If you're using the handle system, for example, I found an entry in Wikidata that one can point to. In accessibility, I found an existing entry in nano publications pointing to digital object interface protocol. And I'm going to talk about nano publications in a few slides. Likewise, for interoperability, I found an existing entry in Wikidata for JSON LD. So I mentioned that this Fip Wizard points to nano publications. So this pre-symposium workshop had us using this tool called NanoBench. And what this tool does is allow you to mint triples as RDF in, I think there's a federation of servers. I think there's at least 2 servers, but it allows you to mint RDF and publish it to the World Wide Web. So this is just a screenshot of me using this tool called NanoBench, and I created a triple to define Materium as a fair implementation community. And this tool created a persistent identifier using Perl to that little bit of RDF. And this tool has a number of sort of templates for creating RDF that sort of matches a pattern. So you can define like a fair enabling resource or fair implementation community. And there's a number of other interesting templates baked into this tool that was presented by the organizers in this pre-symposium workshop. This is just me filling out the form, the template that pops up for a fair enabling resource. So it's basically fill in the blank, defining this resource or thing that you want to register as a triple. And I filled it out and I pushed the button and I created this this assertion, this nano publication using this tool. And now I can point to this nano publication in the FAIR implementation profile. And you can see that I've done that here. Okay, so I showed this slide before, and I believe this is my last slide. So I sort of asked the question to the floor: what should the priority be for this informal task group? And I'd like to thank everyone for their time.
Do we have any questions out there? Perhaps we should move on then.
Okay, then I guess we can get into our panel discussion. Our panelists up, representing China and the US, will discuss the challenges and goals of the materials data community in their respective regions. From China, we will have Chuang Cheng coming shortly, I believe. From the US, we will have Gretchen Green and Zach Trott, who will also moderate the panel discussion.
Do we have Chen Chuan on the call?
I'm not seeing him. Laura sent him a reminder.
Yeah. So we had a gap in the program, and Laura and I tried to put something together sort of last minute. I see a chat. Oh, Asahiko has a question. Oops. Is there a place where I can see the inventory of semantic assets collected by the task group so far? So yeah, a subset of those are at the Materials Resource Registry. And Ray presented the link in his presentation. I'll paste that into chat.
Actually, if you just scroll up in the chat, you should see it there.
Thanks, Ray. Are there any other questions? Just bear with me. I'm adjusting things on my monitor. So since we don't have all of the panelists, we originally invited 3, and I think we're missing 1. So I'd like to change this up a little bit. Why don't we do audience participation?
That sounds like a good idea.
Does that sound good to everyone?
Yes.
Yes, that sounds great.
So I'm gonna ask the question, and I'm gonna paste the question into the collaborative meeting notes. So could everyone navigate over to the collaborative meeting notes and push the little yes check mark on the participants list to let me know when you've gotten over to the collaborative meeting notes. And what I'll do is ask the question, and folks in the audience, please sort of unmute to answer your question, and also type your answer into the collaborative notes. Does that sound good to everyone?
What are we? How are we supposed to assent on the notes page? You said press on the something.
Oh, so there's a yes checkbox in the participants to say that you have access to the collaborative meeting notes. I think folks could also just say yes in chat, or unmute and say yes.
Or just let us know if you can't get to the document.
Yes, that works too.
Are you going to type the question at the bottom after
Yes.
under? Okay, so go to the bottom below the sign up sheet. Okay.
So let me look at the time and try to gauge. So we will have what, a half an hour to discuss. All right. All right. First question coming into chat or into the collaborative meeting notes, and let me change the font size. Bear with me for a moment. Let's make this a heading, and then let me make a list of bullets where people can start to answer. Oops. I don't know how to make a list of empty bullets, so I put in some letter A's. All right, so first question, within the materials data community, what do you see as the greatest successes over the past 5 years? Why did these successes occur? And what are the most important lessons that we can learn? So folks, feel free to type in your answers, unmute to answer verbally, or sort of give a story or narrative surrounding your answer.
So Zach, you'd prefer us type directly in the document, or do you want some comments at this time as well?
Both, please. The benefit of typing into the document is so that way individuals who aren't able to join us at the plenary will be able to see our discussion.
Sure.
So both, please.
Right. No, of course, I like whoever, since everyone's anonymous right now that seems to go into this document. I don't know who wrote MGI there, but it wasn't me. But yeah, I mean, I had a colleague a few years ago say that, you know, what changed is nobody's talking about why we should share data anymore. They're talking about how. And I would count that as the greatest success. Almost everything else then becomes tactical, right?
So somebody typed in MARTA. Will somebody on the call tell us what MARTA is and why it's important?
Well, I didn't type it in, but I guess I can talk about it. So
that would be me, Dave, but you can go ahead and talk about it.
Cool. So, or you can, Bob. MARTA is the Materials Research Data Alliance. And that, oh, I'm getting echoed here for some reason. That is relatively new effort that came out of a summit on big data and cyber infrastructure a year ago now. And it's our domain version of RDA, sort of for materials work in the US and to connect to the rest of the world. There is a website up if you want to see more about it. It's marta-alliance.org. I can type that in the chat. We are working towards our first annual meeting, which will be February 23, 24, 25. So that is just ready to be announced. Yeah, I don't know. What else should we say about it, Bob?
Well, I would say it's a great success in the sense that it's the first time really that at least the U.S. materials community has come together under the aegis of clearly, you know, experts in the domain to build a federation, an open federation of data resources and infrastructure. So I think this is game changing, potentially game changing. I'd like to think that, the astronomy community with the virtual observatory had something to do with this as a pattern that could be emulated. Well, there are many others who were behind this to make this a success, but it's really great to see it taking off. A related thing at NIST I'll just mention briefly is called the Research Data Framework. And this is about, who, what, where is going on in research data. And we intend to engage the MARTA as a kind of a proof of concept, kind of a pilot case of understanding who the players are, what roles they take up in research data. And so I think this is a great start to something that in practice should have happened a long time ago, but nevertheless, now it's going, and that's great. And we have to keep feeding it and making sure that it succeeds.
Yep. Well, thanks. It's, yeah, and the goal is it really, I think some people who are on the RDA side may not see where there's a niche for that domain side, right? There are a lot of people in the materials world who are not going to be major RDA participants. They need something in their domain. So it's really a bridge between those two worlds.
Right. I agree, Dave. There are examples in RDA where disciplines have totally developed their community because of RDA. I think about the agriculture community and wheat and stuff like that, where they really didn't have anything external to RDA. But this is, as you say, Dave, I agree, it's a bridging thing where that independence within that research domain is really important, but also the link into what we're doing here in this working group and interest group is really important as well.
Yep. Yeah, in fact, I was going to talk offline with Ray and others in the NIST group about working on growing that critical mass in the registry through MARTA, as a place to reach people who have data assets and figure out what needs to be done to actually be able to register them and work. One thing that in a practical sense, we don't need to hold this up, Zach's discussion up, but in a practical sense, sometimes the underlying infrastructure being the same between the curation system and the registry is actually confusing to people. They think if they've got their assets in something else, they don't know how they can get into the registry and so on and so forth. So helping get there.
Yeah, that sounds good. I mean, this connection to other capabilities is what I was trying to get at. And, by itself, it's not quite as powerful as it really can be, unless it's can be part of a larger system that can leverage it.
Right.
That's great.
And there were many people part of growing the MARTA effort, but Gretchen was a big part of it in making sure that it was a grassroots effort and really building up and getting people involved. So that makes it valuable to to connect to those people, I think. All right, but now I'll stop. We shouldn't totally waylay Zach's discussion here. Sorry.
No, these kinds of topics are highly encouraged. I believe Professor Chen Chuan has joined us. If anybody else has joined us since we got started. So we're answering the questions as an entire, everyone on the call is answering the questions. I'm going to repaste the link into chat, since I think you can't see the link. You can't see the chat prior to logging on. So if we have any other new individuals joining the call, the collaborative meeting notes, I've repasted the link.
I see Mikiko Tenafuji from Japan has recently joined as well.
Hi, everyone. Long
Hi,
time
how are you?
I'm very fine, thank you. Oh, hi, Jim.
Good to see you.
A strange feeling to connect to live America.
Yes, well, here we are.
Congratulations to, sorry, I shouldn't say that. Okay, good morning, everyone. I'm from Japan, Mikiko Tanifuji from National Institute for Material Science, and I will be making progress in a data infrastructure day after tomorrow at 9 o'clock. So I'm really delighted to be able to join the community again. Really nice to connect and share the problems day to day or homework day back to day.
Indeed.
So I guess I would raise a question. I think Chandler has joined us now, having resolved some connection issues. I would like maybe for Chandler to speak a little bit about the curation efforts. You know, we have a concept that anybody can come and share their resources through the registry. Anybody can come and share an ontology or, you know, a schema. But do we need to worry about this in terms of the quality of the inputs or the long-term support of those inputs? And Chandler spent a lot of effort in working on curation efforts. So I don't want to take over running this meeting, but I think that might be an interesting thing to hear about.
Sure. Can you actually hear me?
We can, Chandler.
Excellent. Okay. So I've been thinking about this question of what does it take to get critical mass for the materials resource registry? And my own answer to that would be that really there needs to be some body or group of people at a number of institutions who see it as valuable to make their resources, their software, their database, et cetera, make those listings available, and that the people at the institutions hosting those things see it as valuable enough to maintain those records. And that doesn't necessarily have to be by running their own registry nodes, but perhaps it is. But even starting with having people who are affiliated with these various efforts having the ability to, for example, have an account on an existing system and to create new records and update them, I think would go a long way if there was enough awareness and interest within the community to do that. So that's part of what I would say about building out critical mass. The other thing I would say is that we've spent a lot of time thinking about what the metadata should and can look like, thinking about what the vocabulary should be as part of the working group. And then also how that plays with things like free text and adding free text descriptive fields and keywords that are presumably material or subject specific. So I think that we've learned a lot over the last 5 years or so working on this project. And that I think Jim is right, that there's been a lot of technical development that means that it's much more user-friendly and easy to work with than it used to be. And so now I think it is at a point where we can really start to build out the system and to build these networks and these collaborative sets of interactions to first create the catalogs and then start really building in the ability to search across the network and to access the data. So I hope that's what you were asking about, Bob.
It was indeed. And Zach, I'm sorry, I'm going to take one more prerogative here and ask my friend and colleague, Susanna Sansone, if she would comment on the curation effort and the community building effort behind fairsharing.org. Are you with us, Susanna?
Yeah, I'm still here. I have my dishwasher going on, so hopefully you don't hear the noise, although it's 1 o'clock in the night. I'm sorry. Yeah, so practical, well, yeah, in terms of curating or the record, it's a lot of work, and thanks Bob for asking. I actually made a comment when early when Ray was talking, talking in the sense of, what is that you need to put in the registry, the NIST registry. And I agree, the number of records, it's not as important as it is important the quality of the description, the interlinks between the different records, so that when a user search for something, it's able to find related information too. And somehow package all this information, curating it and package it for the user, try to understand what user is looking for. It's really very difficult because there are lots of resources out there. So curation isn't just about the description of the resource, but how they are packaged, connected, and presented to the user.
Okay,
and nobody wants to pay for this type of activity, obviously, needless to say, Bob.
They just want it to be, right? And
exactly, magically.
Thank you, Susanna. Okay, I will relinquish my faux chair position here and let others speak.
Hello, everybody.
Hey, hi.
Hi, could you hear me?
Yes, we can hear you.
Okay, everybody, I'm Chen from Shanghai University. Thanks, I'm very glad to attend this discussion. And since I have established some material database under the funding support from Shanghai government and some funding from Chinese central government, so I have some ideas to share with you. First, I mean, I think materials, maybe whether we can build a materials ImageNet, ImageNet is an open data set. I want the user community can establish an open public data set like ImageNet. That's a world open image database for image processing area. In addition, ImageNet accelerated big progress in image processing as algorithms, especially deep learning algorithms. So whether we can establish a materials ImageNet to accelerate the materials image processing area. The second point is material data copyright. The problem is how to encourage the data provider, the material data provider, to provide the data freely and willingly. In ImageNet, most of the images, animals, sceneries, so not as valuable as material data. So how to protect the data copyright of those valuable material data? Maybe it's a key bottleneck in this area. I think maybe blockchain or handle system can practical techniques options for to provide the data copyright techniques to protect the copyright of the data providers. The third idea is how to search the data effectively and efficiently according to the end users' specific requirement. In this area, I think the registry system as NIST developed is a good choice, which can integrate different data in one single system. But in order to integrate data more semantically, several new technologies like knowledge graph or semantic network can provide more help. The last one is once we got a big open material database, machine learning for material data is also very important. Currently, there are so many machine learning algorithms we can use, but how to select them effectively is a big challenge, especially for material scientists. So I mean, if we can provide a software studio to do machine learning automatically and intelligently, is a good way. So another advice is for material science, sometimes designing or telling the user what is the most possible experiment I mean, tell the material scientists how to select the next experimental candidates is more important than just the traditional machine learning prediction. So in some extent, single or multiple object optimization algorithms sometimes more important than traditional machine learning algorithms. Last, I think it's very important for our material data community to provide more communication and cooperation opportunities. So this is a good way to do more great job for our community. That's my ideas. Thanks.
Thank you for joining us, and thank you for your input. So I've posted the next question. I only have 3 questions prepared. So within the materials community, what are the most important goals for the next 5 years? I.e., what do you envision as the future state of the community and infrastructure? And I'd like to thank Bob for some of the questions he asked. So the answers that Chandler and others have made, please post those into the responses for the future goals around critical mass and things related to critical mass.
One question I have for the group is around data sharing to different material researchers in terms of disciplinary orientation. I wonder if anyone has any thoughts related to, for example, in the area that we're working with in biomaterial research, there's a lot of developments in materials design and product design, as well as material science and chemistry, et cetera. So I'm very curious about bridging those gaps in terms of, or bridging those disciplines in terms of how to talk to one another.
That is, this is Bob. That is a great point, because you know, the cost of building integration layers can be immense, and it has to be, in my view, driven by the use cases that will result, or that will be served by that integration. This came up earlier today in another breakout session, and it's something we really have to bear in mind. I think within materials, and my experience in materials goes back all of 6 years now since I came to NIST. So I'm very much still learning. And in contrast to astronomy, where basically you can characterize observations by where they are in the sky, what bandpass they were taken in, and what time they were taken at, materials is way more complicated, way more complicated. So, you know, you have to ask, well, where does it make sense to integrate data from an electron microscope with a mass spec, with a X-ray diffraction experiment, et cetera? What are the scientific questions that will be answered by those kinds of integrations? And if there are serious scientific questions that can be answered, well, yes, we need to pursue them. But we have to avoid the pitfall of designing solutions for which there are not compelling problems to be solved.
That's a very useful point, for sure. Yeah, thank you.
I think you could add to this. This is Alicia, right? And
yes, that's right.
Because you're working in a domain that is already trying to integrate data from disparate sources to solve some really pressing global level problems. But you have to make choices, don't you, about where you put your effort?
Yes, certainly. And I think that's that is definitely motivating my question in terms of there's a lot of the compelling use cases are actually around what are the most pressing challenges from a waste perspective in plastics. So when we're talking about what's compelling for people to contribute to collective problem solving and actually share data, et cetera, domains that will galvanize people are often around like what are the most pressing challenges, for instance, packaging in plastics. So that's also crossing not only scientific domains where people would be able to contribute various data sets, et cetera, but also application versus scientific domains. So, you know, people who are looking at data that is very specific to an industry sector, or a market niche. So yes, that's very true.
And Alicia, do you have to get private sector people to be willing to expose data that they might otherwise consider as proprietary?
That's a proposition that we haven't really looked under the hood yet, to be honest. I think what we're working with is the idea of first coming up with compelling tools, visualizations, and data that can demonstrate to industry folks that sharing data is useful. And kind of do a demand pull sort of thing where if people see it as useful, they could contribute perhaps a pre-competitive data set or something like that. But to be honest, that's a whole set of questions that we haven't yet really dove into with real people, you know, to actually get feedback on that. But I think it's a super interesting question to get into for sure.
You know, it's not the industry question. It reminds me that it's not unlike what we do when we deal with sensitive, secure data as well. And we have lots of programs that we work with DoD researchers where we use a canonical model. So we have data that is open, but is not, and that is then translatable. We develop tools that they can use with more secure information. And that provides sort of a barrier in that sense as well that can protect things with a little more IP interest as well, I think.
Interesting.
All right. In the last 8 minutes, I've posted the third and final question. What are the greatest gaps, challenges, and risks that we need to overcome to achieve the 5-year goals that you were thinking about in your previous answer? And if anyone doesn't have access to the Google Doc, feel free to unmute and speak your answer, and I'll try to get that written down.
It's Mikiko speaking. I think that one of the greatest challenge would be how to identify between the human capability and machine capabilities in terms of data curation and sharing. The approach, the reason why it costs so much, which we also experience, is that why should we talk about data sets to share between your group researchers or between other research institutes, and then the depth of the discussion and the height that you aim to reach becomes so huge. But there isn't really a discussion yet at this stage of this game that how much we can expect machine or machine learning type of approach to replace the human work. Because we need to accept economical level that we can pay for and leave machine to translate for us and machine to produce a machine readable manner data sets for sharing. That's related to the previous topic. I think that the more you need to specify, the more the cost we have to pay for. And normally people are not capable to pay for the time cost. So, well, that's the one idea.
Yeah, Mikiko, I totally agree with you. I just added a bullet point about,
Thanks.
you know, the one thing that we struggle with in our laboratory information management systems work at NIST is, you know, we can reverse engineer metadata extraction from proprietary formats and so forth, and we can figure out what the operating conditions of the instrument were. We can't capture the intention of the experimenter. That has to be something that somebody writes down, right? Until we have brain probes, you know, that can extract that information automatically, that is something that is really important, that requires still, you know, human intervention.
It's often hard to regulate. Don't go too deep. People's sort of comprehensive level is not that deep, and people don't have much time to cope with.
Yeah.
So really, for example, in materials, particularly polymer science data sets that we try to share with polymer science in biotechnology area, and we, of course, have a different idea and different level specification of the description of the polymer materials, but it's forever discussion and high cost to redesign the databases to RDF, and then who is going to provide ontology for the RDF, and then it's going to be lifetime work. And so I feel that some point or some depth we should export to machine to deal with it, and we should use our time to a little bit more quality, so sharing the concept of the quality of the data sets. How much quality do you need, really? That sort of discussion we have every day here.
Yeah, that's a good point too, in terms of assessing quality. My experience in astronomy was basically, we had a reputation-based system for assessing quality because the community is very small and people knew who to trust and who not to trust. In materials, the community is 2 orders of magnitude bigger and it gets way more complicated.
Reputation still is huge though. So, I mean, because the social network's just deeper, right?
Okay.
Right. But, you know, but it's still, I mean, look, it's academia, right? By and large. So, I think this has got to be largely true, even in industry, right? I mean, it's the same set of processes because it's one of the only systems we have. I actually think overlaying a, social credit system on top of this is something I've had a fantasy about doing for a long time. I think we're probably going to start getting closer to being able to do it soon, just like you have, verified users on Twitter and, star reviewers on Amazon and all this other stuff. We'll get there. It's just going to take a little bit longer, and it's a sort of chicken and egg thing. So right now we're all, as Chandler was talking about, trying to figure out what the, critical mass kinds of things are. How do we get over this hump so that it's a fait accompli? So to me, it's about creating things that people want to use. Then, we start to not have to put as many cookies out there, right? But, we'll get there. So anyway, I really enjoyed this discussion.
Yeah. Very good.
So I think we're pretty close to time, aren't we?
We have another session Wednesday?
Correct. I think I get to run that show.
Right.
So I look forward to that discussion. Brittany, do you have any requirements on us as we exit this?
No,
we really appreciate you taking care of all the technical details for us. Thank you very much.
No problem. Thank you, Jen. Thank you, everyone, for joining today's session.
Yeah.
Fantastic. All right, all. Well, we'll see you on Wednesday, and enjoy the rest of the conference.
Okay.
Thanks, all.
You know, for taking the leadership there too.
Thank you. See you.
Thank
all.
you. Bye-bye.
Bye, everybody.
Bye-bye. Thank you.